Hello everyone, and welcome to this video on the Python programming language. So in this video I will use portfolio optimization to build a tech stock portfolio. Now I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it really easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code. So to get started writing this code, go ahead and click on File, then click on New Notebook, and a new tab will open up for you, and then eventually a new cell will open up for you. Now in this cell, I'm going to put in some comments. I'm going to put in a description about the program. So I'm just going to type here, use portfolio optimization to build a tech stock portfolio. Okay. And then I'm going to create a new cell by clicking this code button here in the top left. And in this cell, I'm going to import the Python libraries that I'm planning on using throughout the program. So I'm going to import pandas as PD. I'm going to import numpy as NP. Okay, and then I'm going to run this cell by clicking this button here to the left, and this will let us know if I made any mistakes or not. Also, before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell notification. Also, you can get the code or the dataset or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. So all of the code and the dataset you can get from patreon.com/computerscience. And the material in this video is purely educational and should not be taken as professional investment advice, as I am not a financial advisor. Okay, so with all that being said, let's go ahead and continue. So I'm going to create a new cell by clicking that code button in the top left. And now I'm going to load the stock data, the tech stock data. So let me just put tech stock data. And in order to do this, I'm going to use Google's library to load this file. So from google.colab, I'm going to import files. And I'm going to type files.upload to upload the file. Okay, so next I'm going to run this cell by clicking that button here to the left and click on choose files. I'm going to choose this techstocks.csv file. Okay, so this may take some time, but again, you can get this data set from patreon.com/computerscience. And what I'm going to do is I'm going to come back to this video after this is done loading to make it faster for you all. So I will see you all soon. Okay, so the file is done uploading. So let's go ahead and create another cell. And now I want to read in the CSV file. Okay, so to do this, I'm going to create a variable called df and set it equal to pd.read_csv, and the file name I need to input here, which was tech, and I'm just click escape there. All right, so it's tech underscore stocks.csv. Okay, and then I want to show the data. All right, so I'm just going to type df here and let's run this and let's see what the data looks like. Okay, so we can see our tech companies up top here. We can see their stock ticker or symbol, and then in this column we can see the dates, and we have 1,432 rows of data and 306 columns, so 305 of them are just tech companies. And the prices that we're seeing here are the adjusted close price for each of these companies. Okay, so let's go ahead and transform this a little bit. So the first thing that I want to do is I want to drop any NA or missing values, and I don't believe there should be any, but let's just check. So in order to do this, just type df dot drop NA and set in place equal to true, on axis equal to 1. Okay, so let's run this, and we can kind of check this just by looking at df again. So I'm going to run this here, and let's see if we get the same number of rows rows and columns. So we have 1,432 rows and 306 columns originally, and we have 1,432 rows and 306 columns. All right, so do they match up? The answer is yes. All right, so it looks like there is no missing values in this data set. All right, so I'm going to create a new cell, and now in this cell I want to set the date column as the index. So to do that, I just type df dot index and set this equal to pd dot to underscore date time, and I'm going to input the date column. Next, I want to drop the date column. So drop the date column, and that's easy enough just by setting df equal to df dot drop, and then I'm going to input date on axis equal to columns. All right, then I want to show the data, so I'm just going to type df here, and let's run this. Okay, so now we still have 1,432 rows, and we have 305 columns instead of 306 because we got rid of the date column. All right, so now that I'm done manipulating the data set, let's go ahead and let's calculate the simple returns. Okay, so I'm going to create a variable called daily underscore simple underscore returns, and I'm going to set this equal to df.pct underscore change, and I'm going to input the value 1, and then I want to show the daily underscore simple underscore returns. So I'm just going to run this cell, and now we can take a look at the daily simple returns. Okay, so with this calculation, I can now calculate the mean of the daily simple returns. So that's exactly what I'm going to do now. I'm going to calculate the mean of the daily simple returns. So I'm going to create a variable called daily mean simple returns. Okay, and I'm going to set this equal to daily underscore simple underscore returns dot mean, and then I'm going to show the daily mean simple returns. So here I'm going to put calculate and show. All right, so let's run this, and there we go. So now we can see the daily mean simple returns. Okay, let's go and create a new cell, and here I want to show the annualized returns. So to do that, I'm just going to set the daily mean simple returns, and I'm going to multiply that by 252, which is the approximate trading days or number of trading days within a year. Okay, so let's run that and see what value we get, or I'm sorry, values we get. So these are the annualized daily mean simple returns for each of the companies. Okay, so let's go ahead and create another cell. Now here I'm going to sort the values for the daily mean simple returns. Maybe I'll put that here for the daily mean simple returns, and show the annualized returns as a percentage. Okay, so that's easy enough. I'm just going to do daily mean simple returns dot sort underscore values, and I'm going to set the axis equal to 0, so it's going to be sorted by the index. And then I'm going to set ascending equal to false, so that means that this will put this in descending order. Okay, I'm going to make this in place so that it changes the data set. I'm going to set kind equal to quick sort. That's the sorting algorithm that I want to use. And NA underscore position will be equal to last. I believe this is defaulted as last already. It's just going to put all of the NA values at the end of the data set. Let's see, I'm going to set ignore underscore index equal to false, and then I'm going to set the key will be none. So I think that will do it. So there we go. Let's go ahead and show the mean simple returns times 252, which again is the approximate number of trading days within a year. And then I'm going to multiply this by 100 to get a percentage. So let's go ahead and run this. Okay, so that looks pretty good here. Yep. All right. So everything should be in descending order, right? So we can see a few tech companies down here that give a negative return. You probably would not want to invest in this or invest in these companies. But again, I am not a financial advisor, so don't take my opinion for facts or anything like that or for advice. All right, so let's go ahead and create a new cell. Alrighty, and now in this cell, I need to install the Pi Portfolio optimization package. So in order to do that, I just type pip install Pi Portfolio opt. All right, so let's run this. This should be fairly quick. All right, so it's done. I'm going to create a new cell. And now in this cell, I'm going to import some more packages. Import, I'm going to put more packages to create an optimized tech portfolio. Okay, so from pyp fopt dot efficient underscore frontier, I'm going to import efficient frontier. All right, next from pyp fopt, I'm going to import risk underscore models. Also from pyp fopt, I'm going to import expected underscore returns. Okay, so I'm going to run this cell. Everything looks good there. I'm going to create a new cell. And now I want to optimize the portfolio. Okay, so in order to do this, I need to calculate the expected returns and the annualized sample covariance matrix of daily asset returns. Okay, so I'm going to create, and I misspelled the here. So I'm going to create a variable called mu. I want to set this equal to expected underscore returns dot mean underscore historical underscore return. And I'm going to input the data set df. And then I'm going to create a variable called s for the sample covariance matrix. And I'm going to set this equal to risk underscore models dot sample underscore cove. And I'm going to input the df data set there. Okay. All right. So I think that looks good. Let's go ahead and just run this cell and let's create a new one. All right. So the next thing that I want to do is optimize for maximal Sharpe ratio. Okay, so what is the Sharpe ratio? Well, the Sharpe ratio describes how much excess return you receive for the extra volatility you endure for holding a riskier asset. And it was developed back in 1966 by William Sharpe. All right, so let's go ahead and make that calculation. Also, you may be wondering, well, what is a good Sharpe ratio? And I guess a good Sharpe ratio would be a ratio higher than 2.0. Is actually rated as very good, and a ratio of 3.0 or higher is considered excellent, and then a ratio under 1.0 is considered suboptimal. Okay, so let's create a variable called ef, and I'm going to set this equal to efficient frontier. Of course, ef standing for efficient frontier. I'm going to input the variable mu that we created and the variable s, and this will create our efficient frontier object. Okay, next I'm going to create a variable called weights, and I'm going to set this equal to ef dot max underscore Sharpe, and then I'm going to create a variable called clean underscore weights and set this equal to ef dot clean underscore weights. All right, so I think that looks good, and then I want to show the expected return, the volatility, and the Sharpe ratio. Okay, so let's go ahead and just type ef dot portfolio underscore performance. So again, we get to see how well this portfolio is expected to do. So that's the expected return, the volatility, and the Sharpe ratio for this portfolio. All right, so I'm going to set verbose equal to true, and let's run this. Okay, so we can see that the expected annual return for this portfolio is 100.6%. The annual volatility is 45.3%. The Sharpe ratio is 2.18, which is considered very good. And also, I think I did not add that a Sharpe ratio greater than 1.0 is considered acceptable to good by investors. All right, so I think I missed that one ratio when I was determining what's a good Sharpe ratio. So you may notice that you don't know what this portfolio has in it, right? But we can see what it has in it by printing the cleaned weights. So let's print the cleaned weights. Let's run this. Looks like there's a small mistake. I need to put a left and right parentheses here. So let's run this again, and now we can see the cleaned weights. So we can see here we have AAPL, which is the ticker symbol for Apple, and this will be about 2.7% of our overall portfolio. MSFT is Microsoft. It looks like it won't be considered in this portfolio, so we'll have 0% in it. GOOG is Google, and we have 0% in that, 0% in Amazon or AMZN, and we have about 8.419% in Tesla, and so on and so forth for all of these different tech companies. Okay, and this is a lot to go through, right? But that's okay. We can clean this up to make it look a lot better for us to actually see the portfolio, and then to see exactly how much of each we want for a specific amount of money within our portfolio. All right, so let's go ahead and do that. Let's create a new cell. And now I want to install Pulp. So I'm going to type pip install Pulp. Let's go ahead and run this. And it should not take too long. All right, so it's done. I'm going to create a new cell. And now in this cell, I'm going to get the discrete allocation of each share per stock. Okay, so that's going to be using these weights here, right? All the weights here. So some stocks we will have 0 shares in, like Microsoft here. All right, so I need to import another library. So I'm going to import, I'm just going to put import a library. So from pip fopt dot discrete underscore allocation, I'm going to import discrete allocation. Okay, so next I'm going to create a variable called portfolio underscore val, which will be short for portfolio value, and we'll set this equal to 10,000 or 10,000 US dollars. I'm going to get the latest price for the stocks, and for this I'm just going to use the last value in our data set. So that's just df.tell, and then we input the value 1, and then dot squeeze to transform it. Okay, so next I'm going to set weights equal to cleaned underscore weights. So that will give us the cleaned weights. And then I'm going to create a variable called DA, which will be short for discrete allocation. And I'm going to set it, DA, which is short for discrete allocation. And I'm going to set it equal to discrete allocation. So I'm just going to create a discrete allocation object, and it needs me to put in some weights. It needs me to put in the latest price, and I called it latest prices, and then the total underscore portfolio underscore value, which is equal to the portfolio underscore val. All right, and I think that'll do it. So now I'm going to create 2 variables, one called allocation, one called leftover, and I'm going to set this equal to da.lp underscore portfolio. So this will get the discrete allocation and the leftovers, also known as the remaining funds of each share per stock. Okay, so next I'm going to go ahead and print the discrete allocation. I'm just going to put allocation here, and then I'm going to print the funds remaining. Put a little $sign here, and I'm just going to put leftover. Okay, so let's run this. Okay, So now we can see that with $10,000 in the portfolio, this efficient, optimized portfolio says that we should have 2 shares of AAPL, 3 shares of TSLA, 1 share of TEAM, 1 share of CDNS, 14 shares of ENPH, so on and so forth. I think you get the idea. And out of those $10,000, we will have about 5 cents, I'm rounding up here, or 0.0498129129129, so on and so forth cents, right? Okay, and now with this portfolio, we can expect a 100.6% annual return, and we can expect an annual volatility of about 45.3% and a Sharpe ratio of 2.18. Now, of course, anything can happen. The portfolio could drop, the stock market could drop, absolutely anything. Okay, this is just what is expected. It doesn't mean that it will happen. All right, so let's go ahead and create a new cell. And now I kind of want to show this portfolio in a better format. So I'm going to get the discrete allocation values. And to do that, I need to create a list. So I'm going to create a discrete underscore allocation underscore list and set it equal to an empty list for now. Then I'm going to create a for loop. So for symbol in allocation, I want to append to that discrete underscore allocation underscore list. So I just type discrete underscore allocation underscore list dot append, and I want to append the allocation dot get symbol. Okay, so let's run this. All right, and create a new cell. Now in this cell, I'm going to create a new data frame for the portfolio, and this will help me format it in a better way than what we previously have seen. So I'm going to create a variable called portfolio underscore df, which will be portfolio data frame, right? It's our data frame that I plan on creating here. I'm going to set it equal to pd dot data frame, and I want to give it a few columns. So I'm going to set columns equal to company underscore ticker. So that's the ticker symbol. I'm going to make this a capital T, and then the discrete underscore value underscore, and then I'm going to put in the portfolio value. So portfolio underscore val, but I need to cast this as a string. So I'm going to type str and surround it with that function. Okay, and then I need to make sure I have my right square brackets finished there, and then I need to finish the data frame method with that right parentheses. All right, so hopefully, let's see, hopefully I have this. Oh, gotta get rid of that right there. And now I think I am good to go. All right. Okay. So let's go ahead and add data to the data frame. So portfolio underscore df company underscore ticker, that's the company ticker column. I'm going to set this equal to allocation. Then for portfolio underscore df discrete column, so what I'm going to do is I'm just going to come up here, I'm going to highlight all of this here and copy using Control C. Then I'm just going to come here and paste it using Control V. Okay, so now that's the same column name. I'm going to set this equal to discrete underscore allocation underscore list, and I'm going to create another column, portfolio underscore df, and I'm going to call this column price, and I'm going to set this equal to the latest underscore prices at position allocation dot values, or so yeah, allocation will be the company tickers, right? So I want the latest prices for those company ticker symbols. All right, so well, let's show the data, right? So let's show the portfolio. And in order to do this, just type portfolio underscore df. So let's run this. I hope I didn't make any mistakes here. Alrighty, so now we can see the portfolio, and I think it's in a much better format. So for a portfolio that has about $10,000 in it, this will be your this will be the number of stocks that you want for each of these company tickers, and this would be about the price, at least in this case according to the last price in our data set. And we can again expect a 100.6% annual return. We can expect a 45.3% annual volatility and a Sharpe ratio of 2.18. It is not guaranteed, but anyways, I hope you all really enjoyed this small little fun project, and that's the end of the video. If you want to start an investment portfolio of your own, you can click on the links below and get 2 free stocks valued up to $1,850 on Webull when you deposit $100 or more. And don't forget to grab $10 worth of Bitcoin using the BlockFi link below when you deposit $100 or more. Thanks for watching, and thank you to the supporters supporting this channel on patreon.com/computerscience, where again, if you would like to be a supporter on patreon.com/computerscience, I will leave a link in the description below for that. Thank you for watching, and I hope you all have a great and fantastic day, and I will see you all in the next video. See ya.